Welcome, curious minds, to another deep dive. Today, we're tackling a scenario that sounds, well, straight out of a Hollywood blockbuster.
Right.
But maybe one that actually offers some surprising reassurance about the technology we, rely on every day.
Okay, let's unpack this. So imagine this. You're cruising, say, 35,000 feet.
Yeah.
Boeing 737-800, smooth flight, totally uneventful. Then the unimaginable happens. Suddenly, there are no pilots, no cabin crew, and you, a passenger, you're the only one left standing with access to the cockpit.
Wow.
Could you, just with instructions from air traffic control, could you actually land that plane? It's a terrifying thought, yeah, but our deep dive today explores the maybe astonishing answer.
And this scenario, it's extreme, obviously, but it raises a really important question for anyone who travels by air, like just how much automation and external guidance is built into modern aircraft for exactly this kind of crisis.
What's truly fascinating here isn't just if it's possible, maybe, but how a complex, highly trained skill like flying could potentially be broken down, distilled into a series of steps that, well, almost anyone could follow with guidance.
So our mission today is to explore a really interesting source. It's an excerpt from a YouTube video called How You Can Land a Passenger Aircraft, 12 Steps by Mentor Pilot.
Mentor Pilot. Yeah, good stuff.
He outlines about 20 steps, give or take, to get an aircraft safely on the ground. And he emphasizes, this is purely for reassurance, understanding, not actual instruction.
Definitely not instruction.
Definitely not. So we'll take you through the critical phases, highlight this incredible reliance on external guidance, ATC, and just the design that makes the seemingly impossible technically achievable, maybe?
It's designed to give you those aha moments, I think. A fresh perspective on all the hidden intelligence in modern planes.
Okay, so let's get into it. The initial emergency. Hashtag the initial emergency and the first crucial steps. So you find yourself in this incredibly dire situation, maybe something like that Helios flight scenario where pressurization went wrong, adrenaline's pumping. But you have to act. What's the very first thing, mentally, physically?
Well, the first recommendation from the source is simple but maybe profound. Sit down, first officer's seat, right-hand side, take a deep breath, and try very hard not to panic.
Easier said than done.
Absolutely. But the aircraft is likely still flying its last course, autopilot still engaged, probably.
Okay.
But the absolute first, most critical step, you have to establish contact with air traffic control, ATC. Without their guidance,
the
source basically says landing is impossible.
Impossible. That's a strong word. Why? With all the automation we're going to talk about, why is that human connection still so absolutely critical?
You don't know where you are, really. You don't know the nearest suitable airport, the weather there, the frequencies, the courses, all the context. ATC provides all of that.
Yeah.
They're your eyes, your flight plan, your instructor, all rolled into one. Without them, you are flying blind, literally.
Okay. So assuming you're, relatively calm, ready to communicate, how do you even talk to them? Where's the button?
Right. So first, find a headset, put it on. Then ATC, once you contact them, or even before, you'd look for the communication panel. It's usually on the center console, that big thing between the seats.
I got it.
And you need to tune the international emergency frequency. That's 121.5. You'll see knobs, big and small, to dial that in. Then there's usually an arrow switch to make it active.
Okay, dialing it in and then making sure my voice actually goes out, not just listening.
Good point.
Yeah.
Yeah, nearby there's the audio control panel. You got to select the right radio, probably labeled something like VHF2, adjust the volume, maybe to the middle 12 o'clock position.
Right.
And then there's a crucial switch, often near the gear lever, maybe labeled RT for radio transmit. You toggle that to the RT position. That ensures you're actually broadcasting on 121.5.
Okay, so comms are theoretically open. What do you actually say, and how do they, instantly find your plane among all the others up there?
You press the transmit button, and you clearly state, Mayday, Mayday, Mayday. Then your airline name, if you know it, or just the flight number, where you were coming from, where you were going.
Okay.
And crucially state, I am a passenger trying to fly the aircraft. That gets their attention.
I bet it does.
Then, to help them find you instantly on radar, you change the transponder code. It's usually another box near the radio. You use the knobs again, set it to 7700.
7700.
Yep, that's the universal emergency code. It makes your little blip on their screen flash, basically. Flags use an emergency. They'll find you fast.
So you're basically lighting yourself up on their radar. A digital SOS, like the plane wants to be found.
Pretty much, yeah. Hashtag, taking control and guiding the aircraft.
Okay, you've made contact. ATC knows you're there, knows your emergency status. Now, the really big question, how do you start to actually control this thing? What's the first thing ATC would need to know from you?
Right. Once they've got you, they'll likely want to know how much fuel you have. And maybe your distance to a landable airport, though they could probably see that.
Where do I find the fuel info?
Usually on one of the main screens, maybe the middle one, bottom right, it'll show total fuel, maybe in tons or pounds. The source mentions like 4.5 tons, for example. That gives ATC your endurance, how long you could stay up.
Okay, fuel check. And then the actual flying part. How do you tell this incredibly complex machine what to do if you're not, grabbing a joystick?
You don't grab the yoke, no. Control really begins with the autopilot panel. It's usually a strip of buttons and knobs above the main screens. Think of it less like steering and more like programming a route.
Programming.
Okay, ATC will guide you. They'll say set altitude 3,000 feet. You find the altitude window, turn a knob to 3,000. Then they'll say press a button off an LVL CHG, level change.
Level change, okay.
You press that, and the plane starts descending or climbing on its own, holding the current speed.
So it's descending. What about changing direction, pointing it towards the airport they want you to go to?
Exactly. On that same panel, there's a heading window. ATC gives you a heading, a compass direction, like fly heading 270.
270.
You turn the heading knob to 270, then you press the heading select button, often just labeled HTG SEL.
Okay.
And the aircraft just turns, smoothly banks, and rolls onto that new heading. You're using the autopilot to control altitude and direction now.
Wow, it really does sound like the plane's doing the heavy lifting and you're just inputting the commands. Any other quick adjustments needed as you're getting set up?
Yeah, one important one, especially if you're at high altitude. Speed is often shown as a Mach number up high. For landing, you need indicated airspeed, IAS.
IAS.
Right, so there's an IAS amps window on that panel too. ATC might tell you to press a button, often CO for changeover, to make sure it's showing IAS in knots. That's critical because all the landing speeds are based on IAS. Got it. IAS, not Mach. Makes sense. Okay, you're descending, turning, talking to ATC. What about just getting comfortable and safe?
Yeah.
Anything in the cockpit you need to adjust for yourself before things get really busy?
Absolutely, good point. While you have a moment en route, adjust your seat. There's usually a lever, maybe on the left side, an H lever sometimes, to move it forward or back.
Okay.
You need to make sure your feet can comfortably and effectively reach the rudder pedals down underneath. Those pedals are vital after you land.
Rudder pedals.
What do?
They steer the plane on the ground, on the runway. Think of it like steering an old go-kart or maybe a boat tiller. Use your feet to keep it going straight down the center line. Small inputs.
Okay, feet on the pedals. Anything else?
Yeah, simple one. Put your seatbelt on, make sure it's fastened.
Right, good call. And one more quick but maybe vital point on talking to ATC. You mentioned the RT switch. Is there a wrong way to transmit?
Yes, definitely. When you're talking, always use that dedicated RT switch on the audio panel. The source is very clear. Do not touch any transmit buttons you might find on the yoke, the control wheel itself.
Why not?
Huge risk of accidentally bumping something else on the yoke, mainly the autopilot disconnect switch. If you disconnect the autopilot unintentionally, well, you're suddenly flying manually. And that's a situation you absolutely want to avoid. Stick to the RT switch. #tag, preparing for autoland. The technical setup.
Okay, so you're positioned right, you're descending, talking safely to ATC. Now we get to the really, really interesting part. Preparing the aircraft for an autoland. What does that even mean exactly, and how do you set it up?
Autoland means exactly what it sounds like. The aircraft, using the airport's instrument landing system, or ILS, essentially lands itself. It flies the approach, flares, touches down automatically.
Wow. Okay, how do we enable that magic?
ATC guides you. It involves setting specific radio frequencies and courses. Down on that center console again, probably below the main radio you used, there are usually 2 more radio boxes. These are for navigation for the ILS.
Right.
ATC will give you a frequency, let's say 110.5. You'll need to set that frequency into both of these boxes. Then there's usually a transfer or TFR button to push, making 110.5 appear in the active window for both. That tunes the ILS.
Okay, frequency 110.5, set and active in both boxes. What about the course? You mentioned course.
Correct. Right next to those ILS radio boxes, there are usually 2 course selector knobs. ATC will give you the runway course, say 223 degrees.
Okay.
You dial 223 into course selector 1 and also into course selector 2. This tells the autopilot the exact direction, the inbound path of the runway centerline beam it needs to follow.
So frequency tells it which beam, course tells it the direction of the beam.
Exactly. You're tuning into the runway's invisible radio pathway.
Incredible, but we can't land at like 300 knots, right? How do we slow this thing down safely?
Right. Step by step. Back up to the autopilot panel, the speed window where you checked IAS earlier. ATC will instruct you, maybe from your current speed, say 280 knots, they'll say, reduce speed 210 knots.
Yeah.
So you dial 210 into the window.
Okay, speed coming back, and then you start configuring the plane for landing, like flaps and stuff?
Precisely. Once the speed is coming down, maybe around 210 knots or so, you start deploying the flaps. Those are the surfaces on the back edge of the wings. They increase lift and drag, letting you fly slower. You'll find the flap lever, usually a handle to the right of the main thrust levers. You move it down to the first setting, maybe labeled flap 5.
Flap 5, okay. Any other safety things to set up for the landing itself? Like braking?
Yes, 2 crucial ones for stopping after touchdown. First, somewhere usually prominent, maybe above the center screens, there's an auto brake selector knob.
Auto brake.
ATC will likely tell you to set it to number 3. That selects a medium level of automatic braking once the wheels are on the ground, so you don't have to think about slamming on brakes.
Okay, auto brake 3. And the second thing?
Arming the speed brake. That's usually a separate handle, maybe to the left of the thrust levers. You lift it slightly and move it back so it rests on a little edge or detent. It's now armed.
Armed. What does that mean?
It means that as soon as the plane senses weight on the wheels at touchdown, those big panels on top of the wings, the speed brakes or spoilers, will automatically pop up to create drag and help slow you down really quickly.
Got it. Auto brake 3, speed brake armed. Flaps 5, speed coming back, ILS tuned. Feels like we're getting there. Hashtag the automated approach and landing. Okay, so the plane's being guided by ATC. You've set the radios, the course, speed's reducing, auto brake and speed brake are ready. We are getting close. What's the single most crucial button press on that autopilot panel to actually start the auto land sequence?
This is, absolutely critical. In the middle of that mode control panel, you'll likely see 3 main mode buttons, maybe LNAV, VOR, LOC, and approach. You must press the approach button, often labeled APP.
Approach.
When you press it, it should light up, usually green. That means the autoland mode is armed and engaged. The aircraft is now actively looking for those ILS signals you tuned in.
Approach button pressed and lit. Now, isn't there another step? Something about needing 2 autopilots for autoland.
Correct. For the redundancy and precision needed for autoland, you need 2 autopilots engaged. Look at the autopilot panel again, probably near the top. You'll see buttons for the command autopilots, usually labeled CMD.
Okay, CMD buttons.
One CMD light will probably already be green. That's the one currently flying the plane. To engage the second one for autoland, you need to press the other CMD button, the one that isn't lit.
Press the other one, not the one that's already green.
Absolutely vital. If you press the one that's already green, you'll turn the autopilot off. Big alarm, manual flight. Bad news. You need to press the unlit CMD button. Then you should see 2 green CMD lights.
2 green CMD lights. Got it. Command A and Command B, or similar.
Exactly. With both engaged, the aircraft is now fully set up for the autoland. It's ready to fly itself down.
So the plane is basically taking over now. What should you expect it to do as it lines up? And you mentioned, don't panic. Why? What might happen?
Right. So the plane will first capture the localizer beam. That's the horizontal guidance, lining it up in the runway centerline. When it does this, especially if it was a bit off course, the plane might make a, fairly assertive turn. It might feel quite abrupt, even violent.
Okay.
Then it will capture the glide slope beam. That's the vertical guidance. It will pitch the nose down to follow that slope towards the runway. Again, these are totally normal automated maneuvers. It knows what it's doing. Don't be scared by the turns or the pitch changes.
Trust the machine. And while this is all happening automatically, you're still manually adjusting flaps and speed, right? Following ATC instructions.
Yes, exactly. The automation is handling the path, but you're managing the configuration. As you get closer, ATC will have you reduce speed further, maybe down to 170 knots first.
Okay.
Then as you slow down more, you'll select more flaps, move that lever down to flap 15, then reduce speed again, maybe to around 155 knots.
Flap 15, speed 155.
And then finally, for the actual landing configuration, you'll move the flaps all the way down, maybe flap 40, and bring speed back one last time, perhaps to, say, 145 knots, depending on weight.
Flap 40, speed 145. How do you know these speeds are safe?
Your main flight display screen, the one right in front of you, will usually show little markers or bugs on the speed tape. These indicate the minimum safe speeds for each flap setting. As long as your commanded speed, the number you dial in, is above that minimum bug for flap 40, you're good. ATC will give you the right final speed anyway.
Okay, bugs on the display. Got it. What's the last major thing? The big one you got to remember before the wheels hit.
Landing gear. You need wheels to land on.
Right. Yes, landing gear.
There's a big lever, usually pretty obvious, often shaped like a wheel or tire, right there in the middle of the console. You move that lever down.
Move it down. What happens?
You'll hear it. A definite rumbling noise, maybe some vibration, as the gear doors open and the gear drops into the airflow. Then, crucially, you look for 3 green lights, usually near the gear lever. 3 greens mean all 3 gear legs are down and locked safely.
3 greens, okay.
At this point, autopilot flying.
Mm-hmm.
2 CMD lights green, gear down 3 greens, flaps 40, final speed set, auto brake 3, speed brake armed, ILS approach mode active. You are ready for landing. Hashtag touchdown and shutdown.
Okay. 10 miles out, maybe less. You can actually see the runway lights getting closer. The plane's flying itself down the glide slope. You start hearing the automated voice call-outs. 1,550, 40, 30, 20, 10. Then what? What happens at touchdown, and what is your job right then?
Okay, so the autoland system does an amazing job. It tracks the center line, follows the glide slope, even flares slightly just before touchdown usually. It's incredibly precise.
Oh.
The second the wheels are on the ground, the autoland is basically done controlling direction. It cannot steer itself on the runway.
So that's where the rudder pedals come in.
That is exactly where the rudder pedals come in. You must use your feet now. Keep the plane tracking straight down that center line painted on the runway. Think like you're driving on a slippery road, small, smooth corrections. Squeeze the left pedal to go slightly left. Squeeze the right to go slightly right. Don't stomp, don't jerk it. Very sensitive.
Small corrections with the feet. What about braking? Do I hit the brakes hard?
No. Critically, do not press the tops of the rudder pedals. Those are the manual toe brakes. Remember, you already set the auto brake to 3.
Oh, right. Auto brake 3.
Let the system do the braking. It will apply smooth, consistent braking automatically. If you hit the toe brakes, you'll disconnect the auto brake, and then you'd have to brake manually, which is much harder to do smoothly in this situation. Just focus on steering with the pedals.
Okay, steer with feet. Let auto brake handle stopping. The plane touches down.
Yep, you'll feel it. The radio altimeter calls out the last few feet. 10, touchdown. You might be instructed by ATC to briefly pull back on the reverse thrust levers. They're usually smaller levers on top of the main thrust levers. Help slow down faster.
Okay.
But maybe not needed.
Yeah.
Your main job is keep steering with those rudder pedals. Keep it straight until the aircraft slows down and comes to a complete stop, hopefully right on the runway center line.
And stop. You've done it. Planes on the ground, not moving. Incredible. What's the absolute final step?
You need to shut down the engines so emergency crews can approach safely. There will be specific buttons or levers, usually clearly marked engine start-stop or fuel cutoff, often above the main thrust levers.
Find those buttons.
Press them or move them to the cutoff position. This shuts off fuel to the engines, and they'll spool down. The cockpit might go pretty dark except for some emergency lighting. That's normal.
Okay, dark is normal.
You might also hear some alarms as the autopilot finally disconnects or system switch to battery. Also normal. Don't worry about those. At that point, you have successfully landed the aircraft. You've done the impossible. Hashtag outro.
Wow. What an incredible, I mean, deep dive doesn't even quite cover it. What an unexpected journey, right? From potential panic to actually pushing pedals on the runway. It's just remarkable to think a passenger with guidance could potentially navigate that.
It really highlights the incredible layers of automation, redundancy, and just the communication infrastructure built into modern aviation. These systems are designed in a way to simplify unbelievably complex procedures under extreme duress.
Yeah.
It's a huge testament to system design, but also, crucially, to the absolutely vital role of air traffic control in that loop.
It's truly mind-boggling, isn't it? It's not just about knowing which button is which. It's about following a very precise sequence and maybe more than anything, trusting the system and trusting that calm human voice on the other end of the radio guiding you.
Yeah, and what's really fascinating, I think, is that while it seems technically possible, it really underscores that things like critical thinking, staying calm under immense pressure, and just precisely executing very specific instructions, even when they feel counterintuitive, like not hitting the brakes.
Right, don't hit the brakes.
Exactly. Those things are paramount. The system is there to help massively, but it still needs that calm, rational human interface to make it all work in such an extreme edge case.
So for you, our curious listener maybe consider this. In a world that's increasingly run by complex technology, how much do we really understand the systems guiding our lives every day?
Yeah.
From the software in our cars to algorithms online. And maybe more importantly, how quickly could we learn to intervene, to adapt if we absolutely had to? It raises some big questions, I think, about competence, about trust in technology, and maybe about our own adaptability when faced with the truly unexpected. Something to think about.